MAX9724 DirectDrive Headphone Amplifier, Maxim Integrated Products. Welcome to this training module on Maxim MAX9724 DirectDrive Headphone Amplifier. This training module introduces DirectDrive technology in headphone amplifiers and overviews the MAX9724 DirectDrive Headphone Amplifier. Most traditional headphone amplifiers used in battery-powered electronics are single-supply devices operating between a positive voltage and ground. This design results in an amplifier that can pass only positive signals. Audio signals, however, inherently swing positive and negative. So, before a traditional single-supply amplifier can accept the audio signal, a DC bias must be added. However, the DC bias may cause distortion to the speaker, waste power, and unnecessarily heat the speaker. To prevent the DC bias from reaching the speaker, a DC blocking capacitor is typically used. This capacitor, combined with mostly resistive load, creates a high-pass filter. DirectDrive headphone amplifiers eliminate the need for a DC blocking capacitor on the output by eliminating the DC bias. The amplifier enables both positive and negative signals. The negative swing is achieved through an onboard charge pump used to generate the negative supply that tracks the amplitude of the positive supply. The charge pump used in a DirectDrive design requires only two small ceramic capacitors to operate, one flying capacitor and one hold capacitor. These capacitors are typically 1 microfarad and can be as small as a 0402 package. This specification results in a significant space savings when compared to a conventional headphone amplifier with 220 microfarad output capacitors and provides superior performance. Especially critical in compact equipment such as cell phones, PDAs, and notebook computers, the DirectDrive technology can save the cost and space of DC blocking capacitors. By eliminating the capacitors, DirectDrive thus eliminates a major source of click and pop, which is created when the DC blocking capacitor in traditional headphone amplifiers is charged every time the amplifier is enabled. DirectDrive technology allows the headphone amplifier to operate directly from the supply used by the system's major digital ICs. By operating from a supply lower than the battery voltage, the headphone amplifier becomes more efficient. Finally, the output capacitor used in a traditional headphone amplifier can contribute significant distortion to the audio signal at low frequencies. By eliminating the coupling capacitor, DirectDrive eliminates this source of distortion. The MAX9724 stereo headphone amplifiers are designed for portable equipment where board space is at a premium. These devices use the DirectDrive architecture to produce a ground-referenced output from a single supply, eliminating the need for large DC blocking capacitors, saving cost, board space, and component height. The MAX9724 suppresses RF radiation received by the input and supply traces acting as antennas and prevents the amplifier from demodulating the coupled noise. The MAX9724A offers an externally adjustable gain, while the MAX9724B has an internally preset gain of negative 1.5 volts per volt. The MAX9724 deliver up to 60 milliwatt per channel into a 32 ohm load and have a low 0.02% total harmonic distortion plus noise. A high power supply rejection ratio allows these devices to operate from noisy digital supplies without an additional linear regulator. Comprehensive click and pop circuitry suppresses audible clicks and pops on startup and shutdown. These devices operate from a single 2.7 volt to 5.5 volt supply, consume only 3.5 milliamps of supply current, feature short circuit and thermal overload protection. The stereo headphone amplifier consists of two 60 milliwatt Class AB headphone amplifiers, undervoltage lockout, shutdown control, charge pump, and comprehensive click and pop suppression circuitry. The charge pump inverts the positive supply, creating a negative supply voltage. The undervoltage lockout prevents operation from an insufficient power supply, and click and pop suppression eliminates audible transients on startup and shutdown. Modern audio systems are often subject to RF radiation and sources like wireless networks and cellular phone networks. Although the RF radiation is out of the audio band, many signals, in particular the GSM signals, contain bursts or modulation at audible frequencies. Most analog amplifiers demodulate the low-frequency envelope, adding noise to the audio signal. The architecture of the MAX9724 addresses the problem of RF susceptibility by rejecting RF noise and preventing it from coupling into the audio band. The figure shows the improved RF susceptibility of the MAX9724 compared with an amplifier that is susceptible to RF interference. At the critical GSM frequencies, the MAX9724 offers a minimum of 39 dB of improvement over the typical headphone amplifier. 2 volts RMS is a popular audio line level, first used in CD players but now common in DVD and set-top box interfacing standards. A 2 volt RMS sinusoidal signal equates to approximately 5.7 volts peak to peak, which means that the audio system designer cannot simply run the line out stage from a 5 volt supply. The resulting output swing would be inadequate. A common solution to this problem is to use op-amps driven from split supplies, but this can mean adding extra cost and complexity to the system. The MAX9724A, having the ability to derive 2.2 volts RMS from a 5 volt supply or even a 3.3 volt supply, can often simplify power supply design in some systems. When the MAX9724A is used as a line driver to provide outputs that feed stereo equipment, with a digital analog converter used as an audio input source, it is often desirable to eliminate any high-frequency quantization noise produced by the DAC output before it reaches the load. The gain of the MAX9724B amplifier is internally set to negative 1.5 volts per volt. All gain setting resistors are integrated into the device, reducing external component count. The gain of the MAX9724A amplifier is set externally as shown in the figure. When selecting the external resistors to set the gain, the selection of proper resistor values needs to be taken into consideration. First, choose feedback resistor values in the tens of thousands of ohm range. Since the effective value of the input resistance is equal to the sum of the source resistance and of the input device and the value of the input resistor connected to the inverting terminal of the headphone amplifier, the overall closed-loop gain of the headphone amplifier can be reduced if the input resistor is not significantly larger than the source resistance of the input device. The MAX9724B is able to internally set gain, so the DirectDrive Headphone Amplifier requires only 5 small capacitors to complete the amplifier circuit. 2 for the charge pump, 2 for audio input coupling, and 1 for power supply biasing. The input capacitor, in conjunction with the input resistor, forms a high-pass filter that removes the DC bias from an incoming signal. The power supply bypass capacitor lowers the output impedance of the power supply and reduces the impact of the MAX9724B's charge pump switching transients. The typical operation circuit for MAX9724A is similar to the one for the MAX9724B, except it needs 4 external resistors to set the gain of the amplifier.